Baolong Wang from Tsinghua University, and it's my pleasure to present this part of the report, and on behalf of the Subtask B2. This part actually we try to summarize the molecular method and collect the data on actual energy performance of the heat pump in buildings. So my presentation includes those following 4 parts. First part is about the background, as Nicolon said, that the heat pump included the room air conditioner, VRF, and so on, has been applied in many kind of commercial buildings, residential buildings, and industry buildings worldwide. From the survey of the IA, you can see that especially the small capacity VRF room air conditioner is the majority, and but we also see that compared to the lab test performance, especially the COP of the heating and cooling capacity, the field performance could be much different. That's because that the environment of the real field factors is different, such as the ambient parameters is different, and also the insulation will largely affect the real performance of the heat pumps. And also the occupants' behavior is a very important factor affecting the real performance. So the accurate measurement of the cooling and heating capacity of COP or ER is very important, because we need to design the system to make the system has a very good real field performance. So when we try to monitoring the heat pump in the field, we can see that the method can be divided into 2 groups. One group is for the hygienic heat pump, which means that it can be an air-water heat pump or can be a water-air heat pump. So in this kind of system, because people always say that because you have the water loop, so we can test the temperature difference between the inlet and outlet, and we also can cheaply and very easily test the water flow rate. So by that, use this equation, so you can very easily calculate the heating or cooling capacity. By that, you can calculate the COP or ER of the system. Another one, but it seems more difficult if we go to the air-to-air heat pump. So because there is no water, so we must consider the other method. Actually, in this field, we always use 2 kind of method. One class is the air-specific enthalpy difference method, which means that we test the air volume, air mass flow rate, and also the inlet temperature and the humidity of the inlet air, and also the temperature and humidity of the outlet air. So that's one kind of method. Another one, actually, we call that the refrigerant specific enthalpy difference method, which means that we need to test the refrigerant mass flow rate and the inlet specific enthalpy of the condenser or evaporate, and the outlet specific enthalpy at the outlet of the condenser or evaporate. So currently, if we look into the real used monitor method, we can actually, this kind of monitor can be conducted in the indoor side or outdoor side. For the indoor side, there are 2 kind of method. One, we call that the air hold method. It has been very good commercialized. You can see a lot of equipment sell in the market. So there are some air hold you can cover that in the outlet of the indoor terminal. So the air hold introduce all the air outlet of the indoor unit into an air air duct. So the at the outer air duct, you can measure the airflow rate and also the average temperature and humidity of the outlet air. This kind of method always can be used for this kind of terminal. For example, the inlet is very even, which means the inlet temperature and humidity is very even. So by this method, we just measure the 1 point or 2 point inlet temperature and humidity, and use this air hold to test the average outlet temperature and humidity. We can calculate the indoor heat exchanger. So, but what's the drawbacks of this method? It's because that if you cover some air hold at the outlet of the indoor terminal, you will interfere, you will disturb the regular air distribution of the indoor unit. So that makes the real performance may be different from the tested result. Another method, they try to avoid this kind of effect by use the air hold. We call that the air sampling method. They just insulated multiple inlet and outlet sensors, include the air volume, air speed sensor, and also the temperature and humidity sensors. So by this method, you can calculate the distribution of the inlet port and the outlet. So by that, you can calculate the indoor unit heat exchange. So another one, also you can use this kind of method for the outdoor side. This kind of method can be also air hold method can also be used in the outdoor side. It's similar to the indoor side. But for the air sampling method, actually currently they have two kind of method. One is very similar, like the indoor side air sampling method. We call that the static multi-point air sampling method. But there are also some other kind of method. We call that dynamic sampling method, because they develop some kind of automatical robot try to scan the outlet temperature, humidity, and the flow rate, so which can make the system use less sensors. That part is the test method of use air specific enthalpy difference. Another class of the monitoring is use the refrigerant side. We call that the RE method. There are several kinds of RE methods. First one is the compressor performance curve method. What's that? Actually, because if you sell some compressor or you sell some heat pump, actually the performance of the compressor can be provided by the manufacturer. So use that curve. Actually, you can calculate the mass flow rate of the system. So use that mass flow rate and also the inlet enthalpy, specific enthalpy, and outlet specific enthalpy of the condenser and evaporator. So you can calculate the heating capacity and or the cooling capacity. That's the basic idea. So actually, this method rely on the fundamental information supplied by the manufacturer. So if you can get that kind of information, it's more easier, it can be realized. But it's also have some kind of drawbacks because if you want to use that for a long-term testament, long-term monitoring, for example, 1 year or several months, but it's maybe become less accuracy because the compressor maybe become the performance deviation because of variant. That's the main drawbacks. Another method is very similar to the compressor performance curve method. We call that the compressor volumetric efficiency method. Different is that we, based on the catalog data from the manufacturer, we get the curve of the compressor volumetric efficiency. Use that volumetric efficiency and also, for example, the suction density, we can calculate the real mass flow rate in the system, and by that mass flow rate, we can calculate the heating and cooling capacity. But this method also has the same drawbacks, just like the compressor performance curve method. The third RE method, we call that the refrigerant flow rate meters method, which means that we directly install some refrigerant mass flow rate meter, just like Coriolis flow meter. So by that method, we can very accurately test the mass flow rate. But just like we understand, it's intrusive, so you must cut the curves because there's no this kind of equipment in the common, in the field, in the market unit. So it's a curve, and it's also expensive. So it cannot be widely used for many monitoring projects. The fourth one, we call that throttling method, which means that actually we use the performance curve of the expansion valve by testing the inlet pressure and outlet pressure. And also the inlet state of the refrigerant, we can calculate the real mass flow rate in the system. So we can get the mass flow rate, so we can calculate cooling and heating capacity. We can calculate COP or ER system. It's similar. The fifth method actually was developed, was more widely used recently. We call that compressed energy conservation method. In this method, actually, they just use the always existed power consumption meter in the system, because we can very accurately test the power input into the compressor. So by testing the inlet suction state of the refrigerator, suction specific enthalpy of the compressor, and outlet specific enthalpy of the compressor, and we can calculate the mass flow rate through the compressor. So that's a general idea. So this generally we think this kind of method can show a very long-term reliability and independence. So that's all the method we can see from the current paper survey or field survey can be used. Generally, we can see that for the air side method, it's actually probably can be widely used. It's because it's more easier to be adopted. For the refrigerant side method, it's more difficult or need more calculation. So the third part, actually, I would like to show some existing standards protocols for the field monitoring. Firstly, is the Europe specifications. We found that the Finnish standard NTVVS YY5 and Y16, it's a very early standard, and very early standard proposed try to test the field performance of the air-to-air unit. In this standard, they just use the CEC method. We call that the compressor energy conservation method. They test the inlet of the compressor and outlet of the compressor, the refrigerant state, and use the energy conservation of the compressor to calculate the mass flow rate. Here you can see they also considering the heat loss through the shell of the compressor. So it's a very good beginning of use this CEC method. We also see that in the Canada specification in 2022 to 2020 to 2022, the Natural Resources Canada founded field trials of air-to-air variable capacity cold climate heat pump in location across Canada. You can see that in these specifications that they give a very detailed guideline how to test the real performance of the heat pump, air-to-air heat pump. In that guidelines, it includes how to select the seat, how to select the equipment, and how to monitor the parameters, and how to conduct a short-term test, how to conduct long-term testing. So that's in this specific standard. I forgot, maybe it should be used air side method. For the Asia standard, Asia standard 221 actually provide a very detailed method to field measure and estimate the capacity and efficiency of the installed HVAC system. From this figure, you can see they used the air-side method. It provides the uniform method for measurement and the testing procedure for airflow, temperature, enthalpy, and power. Just like I said, this standard adopted the indoor side method. In China, there are also some specifications and standard. Here, I just show you two in the industry standard. One is the specification for measure of on-site performance parameter of air conditioner. Another one is the performance testing of heating and air conditioning system in hot summer and cold winter zone. In this standard, they provide a very detailed information for the system, how to select the testing point in the system. It's much better. You can get a more precise result. Also, they provide how to calibrate how to calibrate your testing method. They provide many kind of working conditions. In that condition, you can test you can use your method in the lab and compare to the current use the lab testing method, just like Nicolon said that maybe we use the air chamber, just like in the traditional chamber testing method. You can compare the error of your testing method. For the existing data, just like actually here I just show you two cases, but in the full report you can get more cases. If you want to get that, you can go to the Annex 8A website. The case one I just show you here is a VRF testing result. It was tested in Middle China. It was tested over 80 days and in the cooling season. Generally, we get some very important conclusion. Generally, the ER of the VRF during test is 3.4 to 4.1. And we get conclusion that actually the operation condition and the performance of the VRF could be very different even it's very close in the same city, the climate very similar, and the building very similar. So that's the main conclusion from this test. Another one is conducted on the room air conditioner, was conducted in Japan. Not only in the cooling season, but also include the heating season. But generally, based on this test, you can see that the compare between the field and the rated performance, the actual COP in the field test is much lower than the standard test rate, G is middle capacity or rated capacity testing result from the laboratory, no matter for the cooling season, also for the heating season. So go to the final part, and from the current research, we can get some very important perspectives. One thing is that until now, there are still not a very good monitoring method. Developing the highly accurate and easy to use monitoring technology of the field capacity is very important, is essential. And based on that, so we need to develop some international regulation or standards for field performance testing. And the third one is large-scale field performance monitoring can provide important information for develop of the new generation high-efficient heat pump or air conditioners. That's the real reason why we try to do this in this Annex 88. And also we see that the optimal control such as demand response management also rely on the field performance monitoring and modeling. So it's a very important part for if we can develop some very accurate and very easy to use monitoring capacity testing method, we can use that in that direction. So that's my presentation. Thank you very much.